Hi Jaydeep. Hi Half Moon. Hi Tippeswamy. Chalo. Let's start. Kids. सेमीकंडक्टर पार्ट 2 पे हम स्टार्ट कर रहे हैं बच्चों. ठीक है. आपका डिनर हो गया या ब्रो? मैं वो ब्रेक दिया था ना आप लोगों को अराउंड व्हाट 8:30 वाली क्लास जो थोड़ा डिले गई. 8:30 से स्टार्ट हुई. आई हैड द डिनर दैट टाइम ओनली. आज सोचा आज घर पे प्रिपेयर करूंगा, टाइम लग जाएगा तो बाहर ही कर लिया. चलो. जॉइन फास्ट एवरीवन. स्टार्ट करते हैं. हाय पूर्विका मैम. अभी तक यहाँ तक सबको समझ आया बच्चों? एवरीबडी गॉट इट? At dinner, everybody. Purvika, Soham, Tippeswamy, Half Moon, Jaideep. As of now, staying in Bangalore, ma'am. Basically from Kolkata. चलो everybody join fast. लेट नहीं कर सकते बच्चों. स्टार्ट कर दे. और 2 to 3 minutes, ma'am. It will start. We are almost done. Just waiting for 1 or 2 students. We won't delay it. Don't worry. Chalo, let's have a recap. Till now, what we have done. So we learned about biasing. What is forward bias? What is reverse bias? So whenever we are connecting a PN junction with P part with the positive terminal of the battery and N part with the negative terminal of the battery, then we call it as forward biased. That's why doing ulta. In that case, what will happen? N connected with the positive. I couldn't hear why you asked. Are you able to hear everybody? Are you all able to hear? एक रिकैप दे दूं. चलो 1 मिनट रुक जाओ. रिकैप करा देता हूं. Just 1 minute. We'll be starting. Okay. It's 10:29. We'll recap fast in a fast way within 2 to 3 minutes of the semiconductor and finish the chapter. Go for PYQ. Okay. Chalo. Not able to see the screen, बच्चों. Are you able to see the screen? Are you all able to see the screen? Hi, Sandesh. Chalo, everybody is able to see. Chalo. Chalo, everybody is there. Chalo, chalo, chalo. Let's start. In semiconductor, in a little recap, we'll study three things: conductor, semiconductor, insulator. Conductor has the highest conductivity. The moment you give current, it will allow the current to pass. Semiconductor, it will do a bit of drama, okay, and then after doing a bit of drama, it will allow. Insulator is straight cut, no. Clear? Chalo. Next, we talk about the band theory. We have two kinds of band. One is valency band, that is the energy level of the combined energy level of all the valence electrons, and the other is conduction band. When the electrons go for conduction, they have a different energy. So that time what they form the band, that is known as conduction band. So for case of insulator, this gap between valence band and conduction band is more than 3 electron volt. So even if we give energy, it won't, even if we give energy, what do you say, the electrons from the valence band won't be able to reach to the conduction band, and that's why the conduction band is empty. Conduction band is empty. Clear? In case of semiconductor, it is less than 3 electron volt. So if by any other hook or crook method, if I give them the energy, they'll be able to travel from, at least a few will be able to travel from valence band to conduction band. So that's why it is partially filled, partially filled. Third, the conduction band and the valence band, they are merged in this case, so or overlapping. So here any electron can go from valence band to conduction band easily. So that's why it is completely filled. Clear, everyone? Chalo. Two types of semiconductors we have. One is intrinsic, the other is extrinsic. Intrinsic is a pure form. Conductivity is intrinsic. We can increase by heating up. See, we want to increase the conductivity, we cannot dope it. We cannot add impurity. So what we can do? We can energize the electrons by heating or by applying our electric field or something else. Okay. Extrinsic, we start doping. What we do? We don't dope it with what do you say, LSD or drugs or something. We just dope it with pentavalent or trivalent. Pentavalent has 5 electrons, trivalent has 3 electrons. Okay. So in one there is an excess of electron, in one there is a need of electron. So that's why we get a p type and a n type. Whenever we dope with a pentavalent, we get one extra electron, and that is creates n type. And whenever we dope with a trivalent, it needs one space is empty, it needs one electron here. So that's why it is a p type. Clear? Chalo. P-type doping we use using P-type we form using trivalent impurity, N-type using pentavalent. Holes are the majority charge carriers in the P-type. Electrons are majority charge carriers in the N-type. Conductivity is due to holes. Here conductivity is due to electrons. It is called acceptor impurity and it is called donor impurity. Chalo. Next, this formula I told you, very important, that before doping we just have Ni, that is number density of intrinsic charge carriers. Okay. So and after doping we will have number density of electrons, number density of holes. So after doping is equal to before doping. So Ne into Nh is equal to Ni square. Important for your exam point of view for the numerical part. How do you form a PN junction? We take a slice thin wafer of P and a very slice thin cut of N. We fuse it. We basically do the barbecue at 600, 500 to 600 temperature, and they'll mix with each other and they'll form a p-n junction. Still they haven't formed the diode. The moment you take a p and a n and connect with a battery, it forms a diode. Okay, so here in case of p and n, what happens? N has more of electrons, p has more of holes. So the electrons wants to come and attach with the holes, and the holes, they are calling the electrons. So what happens due to that? One plate, if you see at the end of the p plate, most of the electrons will come and gather, and at the end of the n plate, most of the holes will come and gather. So this creates a positive plate here and a negative charge here. Due to this positive and negative charge, one potential develops, and that potential is known as potential barrier. Because once it develops, it says, bro, now I cannot allow you, though you have allowed me to form, but now I cannot allow more charges to go here or there. You can't. Okay, clear? That's why it's called potential barrier. Okay, chalo. The barrier made by the potential that is not allowing it to change. Next, whenever we connect a P and a N to a battery, it becomes a diode. When P is connected to the positive end of the battery, it forms forward bias, and N connected to negative, it forms a forward bias. In case of forward bias, students, what you see, this positive part of the battery, it is pushing the positive part towards the potential barrier. So what it does, it decreases the barrier. And see the electrons, the negative part of the plate, it is pushing the electrons. Why? Because we know like charges, they repel each other. So it is pushing the electrons to go more this side. So what happens? The thickness of the depletion region decreases. The thickness of the depletion region decreases, student. Clear? Next, after that, in case of reverse bias, N is connected to the positive and P is connected to the negative. So whenever N connected to positive plate and P connected to negative plate of the battery, we call it reverse bias. Here in this case, see, the plus charge are attracted towards the negative plate, negative is attracted towards the positive plate. So what happens? This region expands, this region expands. Clear, everyone? Clear, everyone? That's the whole recap of the class. Clear? Yes, no, anybody has any doubt, do tell me, otherwise we'll move on to the next. Chalo. Just give me 1 second, student. Clear till everyone? Chalo, chalo. Next we'll read about VI characteristics. VI characteristics. What do you mean by VI characteristics? What do you mean by VI characteristics? Basically, graph between voltage and current. Graph between voltage and current. How they behave. Okay. We change in voltage, how the current behaves, and we change in current, how the voltage behaves. Clear, everyone? Chalo. Now, one line is very important. See, in forward bias case, diode conducts. Very important. Everybody needs to write. Okay. Whenever you have a forward bias diode, it will conduct. It will act as a conductor. And in reverse bias, it doesn't conduct. Reverse bias, it doesn't conduct. Because the charge carriers become so less that it's almost like no conductivity. Clear? This part, everybody clear? And this is what students, it is the, when you will read the rectifier, it is the principle for the rectifier. Half wave, rectification and full wave. This is the basic principle. Clear, everyone? Chalo. Let's see the graph. You all know about the graph. Something like this, it comes, it goes like this, and then here it goes like this. Correct? Clear? Now anybody can tell me which side what to put up, which side current and which side voltage, which side current and which side voltage. Here we have the voltage, here we have milliamps current. Okay, clear? Now see here the values are 0.2, 0.4, 0.6. Between 0.6 and 0.8, okay, almost around this value, we have the cutoff voltage. What we have? Cutoff voltage. What is this cutoff voltage, students? What is this cutoff voltage? The voltage after which it behaves like a proper conductor. See, the current shoots up. The current now shoots up. So cutoff voltage is the voltage after which the current shoots up. Clear? Now, this case happens where in case of forward bias. In case of forward bias, you apply a bit more of voltage. Now you'll say, so you have to ask, sir, why this much of voltage it was not able to be like a conductor? Because we remembered, no, we had a very thin but potential barrier. So it took a bit of time to overcome that potential barrier in this much of voltage. After that, it behaved like a conductor. After that, it started behaving like a conductor. Clear, everyone? And for different semiconductors, the value is different. Clear? Chalo. For germanium, it's 0.2 volt. For silicon, it's 0.7 volt. Depends. Okay. In this case, in the second part, students, what happens? In the second part, students, what happens? It is reverse bias condition. 20, 40, 60, 80, 100. So around this part, okay. So it takes so much of huge voltage to overcome this big potential barrier, Okay. So by the time you provide that much, it almost acts as a insulator, it doesn't conduct. Okay. Clear, everyone? Clear, everyone? So this is known as the threshold voltage. Chalo. Clear, everyone? This part? Everybody? Hello, Half Moon. All going good, bro? And how was Pina Colada? Chalo. Everybody got it till here? Everybody got till here? Very simple, very easy. I gave the definition. So do tell me if you have any doubt. If anybody has any doubt, do not hesitate to ask doubts, okay? Clear, everyone? Yes, no, students. If anybody has any doubt, do tell me. Do not hesitate. Okay. Chalo. And it's a good Shubh Muhurat also to ask doubts. So you can ask before exams. It's a good Shubh Muhurat to ask doubts. Chalo. No doubt. No issues. Next part. Very simple part. Application of diodes. Application of diodes. What are the different applications we need? First, the rectifier part, the rectification part. What do you mean by rectification, students? What do you mean by rectification? Anybody who can tell me what do you mean by rectification? What do you mean by rectification? Or what is the work of a rectifier? Work of our brother rectifier. Is this color okay? What is the work of the rectifier? Sir, AC to DC. AC to DC. Now, why do we need to convert AC to DC? Why not use directly AC? Anybody? Does this question pops in your brain? Sir, why we need to convert AC to DC? Why do we need to convert AC to DC? Converting AC to pulsating DC. Why do we need to convert? Sir, you're telling it's good, we need to convert, but why? Doesn't this question comes up? Sir, why do you want to convert? We are getting no good AC, sir. We'll use that good AC. What about what is a DC? Why we want to go for DC? Because a lot of devices which needs very strong current, they cannot work on fluctuating current. Like if you're doing a welding machine, if you're doing the work of a welding, okay, so you cannot use a fluctuating AC, because here what happens, the frequency keeps changing. So you cannot use that. You need strong one moment, like what you say, without changing or without any change in the frequency, you need a current like that. Okay, so in that cases we need what? Proper DC, proper DC, clear. And in a lot of other devices where the current requirement is a bit high, and if due to the fluctuation they can go bad. Due to the fluctuations they can go bad. Clear? Very good, very good. Chalo, hi Akshay. Chalo, that is also good. Now see, there is way to store it, but not for us. Okay. Second thing is DC. We developed DC more earlier, batteries and everything, lithium and all. So what happens are most of the electronic equipments are DC based. So that's what also one reason. Okay, we suddenly can't convert also, and every devices and everything is made around the DC part. Okay, chalo. To the point, not always, but yeah, AC cannot store a certain amount. Okay, few exceptional conditions are there. Chalo. Next, we'll talk about half wave rectifier. Half wave rectifier. What do you mean by half wave rectifier? We are using one diode to do the rectification, but what happens? We are only able to convert one wave. We are not able to convert both the waves. So that's why it's said a half wave. What is the principle behind it? What is the principle behind it? Anybody? Just now we wrote, no? In forward bias, diode behaves as a conductor, reverse bias as an insulator. Forward bias, diode acts as conductor, reverse biased, diode acts as an kind of insulator. Not a full insulator, but yeah, kind of. Okay, clear? Now circuit diagram I won't be able to draw right now that much. Okay, but I'll draw the input output graph. Okay, I'll draw the input output. Let's see. So what happens? This is my input going plus minus. And if I use one diode, what is the work of this diode will be? What is the work of this diode will be? Only in the positive half cycle where it is positive, it will allow the current to pass. Negative half, it won't allow. Again positive, it will allow. Negative half, it won't allow. Clear? Because when it is negative half, it will be like acting as a reverse biased. So in that reverse bias conduction, it acts as an insulator. So it won't allow the current to pass. So done. Clear everyone? So only half of cycles will get. Hi Karthik, DM14. Same account bro of yours only or like else? Chalo. Clear till here? Clear till here? So we all remember the working. We all remember the working. What was the working? During positive half cycle, 2 to 3. If writing CT or COMEDK bro? Akshay, you're writing what do you say? CET or COMEDK? For CET, 2 to 3 marks. For CET, the average weightage of this is 2 to 3. Can go till 4, but minimum 2, maximum 4. Average 3. Chalo. For negative half cycle, 1 or 2 year can be exceptional also. Okay. Diode is in reverse bias. So does not conduct. Clear? No issues, bro. See here, half wave rectifier, what we have for COMEDK Karthik again fluctuates. Okay. I've just shown earlier. I have the data, I'll show you. Minimum 1 can go to 4 also, but fluctuates, can be 1, can be 4, can be 3. Okay. So fluctuates a lot in COMEDK, but weightage is there. Clear? Weightage is there, but fluctuates a lot, bro. NCT, like almost average per question will be minimum 2. If going up 3 to 4, but minimum 2 will be there. COMEDK can be 1 also. Can be 3, can be 4 also. Chalo. See here everybody, again I'm just explaining half wave rectifier. We just have a one diode. So when the current is, what do you say, in this case when the current is forward biased, means this part of the diode, P is connected with the positive of the battery and this N is connected with the negative of the battery. So in that case it will allow the current to pass. The moment it comes to the negative part, means this polarity changes. Now this is negative and this becomes positive. So here it acts as a what? Reverse bias. In reverse bias condition, it won't allow the current to pass. So every power, what is a forward bias, it will allow the current to pass. Every reverse bias in the negative cycle, it won't allow. So that's why it acts, it converts this AC part to a DC. DC means what? One direction current. Done. Clear? Clear, bro? Shoham? Got it? Clear? Chalo. Up right now, let's see a full wave rectifier. Full wave rectifier, what happens? In case of a full wave rectifier, what happens, students? You have two diodes like this. One D1, one D2. And let's say you're connected with AC like this. Changing part. So right now, first case, it's like this. Positive, negative, positive, negative. So what will happen? So here, let's say in the first case, D1, this is P, this is N, this is positive, this is negative. So D1 is what? Forward biased in this case. D1 is what? Forward biased. It will allow the current to pass. So we'll get this part of the current. Now, In the second case, student, what happens? The polarity changes. Now this is like this. The polarity changes. Now this is like this. So what will happen? This D2 will become forward bias. This D2 will become forward bias and will be getting the current from D2. Clear? Again in the second case, D1, again in D2. So this way we'll be having constant current. This way we'll be having constant DC current. Clear everyone? Clear everyone? Got it everyone? Yes, no, yes, no. Tell me fast, students. Anybody any doubt? Anybody has any doubt? Chalo, clear everyone? Chalo. Nobody has any doubt? Good. Now next is optoelectronic devices. Optoelectronic devices. Now devices came. What are the different devices? One photodiode. So here what is it? It has a transparent window to allow light and it works under what are the important things that you need to know? First the diagram part I'll show. This is P side, so holes we have. This is in between the depletion region, let's say. And this is N side. And it is connected like this, negative, positive. Clear? So basically what is happening, light is coming, attacking it. You already know about the concept of what? Photoelectric effect. So it's basically a device having a transparent window to allow light to come. Will come to Zener also. For CD, I think so. No, 12th portion all is there. Works under RB condition, reverse bias condition. Clear? So we know whenever the intensity, what is say, intensity of light is more than the energy gap of the semiconductor, what happens? One electron hole, they were earlier combined, it splits. Okay, and when it splits, hole runs towards the positive region of the negative region of the battery, and electron, see from this region, one electron hole pair bond breaks due to the energy supplied here. And what will happen? Hole will gush and run towards this, and electron will run towards this, and they'll complete the circuit. Clear? Clear, everyone? And the current is generated. So electron hole pair splits and holes moves towards negative region, negative plate, while electron towards positive plate. And current is generated. Can you anybody tell me an example? Can anybody tell me an example? An example, we use that device pretty often to watch matches and all. It is there in that. See to everybody. See, this is the TV remote you have. From the TV remote, when you put what do you say, when you press the plus button. So what happens? A light goes to the sensor here of the TV screen. This sensor, a photon is going. Let's say it hits. After hitting, what happens? It breaks one electron hole pair and makes the current to happen just for only one electron. So when you press the button one time, the volume gets increased by 1. Clear? Clear everyone? Clear everyone? Chalo. Next, LED. Next, LED. What is the full form of LED, everybody? Light emitting diode. Light emitting diode. Again, this one property. This one is heavily doped. Heavily doped so that it has a lot of, what do you say, electrons and holes. So it's a heavily doped PN junction diode. Forward bias condition, it works. Clear? So basically what happens? In this, basically what happens, students? So during forward bias, electrons, they move towards which side? Electron starts moving towards the P region. Electrons from N side moves towards P. You can see like this. Just a forward bias diagram. Positive plate P, N. So electron from here, it starts going in here. Correct, because electron will be attracted. Clear? And while trying to go in between, a lot of holes are there. So it tries and combines here. The moment it merges with a hole, what happens? Energy is released in the form of photon. The moment it comes, and while going towards the, let's say you're going with a bike with a very good speed of 150, but you forgot that Indian roads, they have gaddas also. They have potholes also. So what happened? Suddenly while driving with 150, you met with one of the potholes. So what will happen with 150? So what will happen? A lot of energy will be released on the bike. Correct. So same thing here. So while going from here to there, electron recombines or combines with holes, and energy is released in form of photons. Clear, students? Clear? Anybody has doubt, do tell me. Anybody has doubt, do tell me. Clear? Shallow. Next, solar cell. Solar cell. I think so you all have studied this all. So just I'm going in brief. If you have doubt, do tell me, and then I'll wait there. Okay. Chalo. Solar cell, what is the? What did Aditya send in the batch? Give me 1 minute, student. Chalo now, let's see. So in the case of solar cell, what we have? In case of solar cell, what we have? You all know the, what is a diagram of the solar cell, or do you want me to draw? Basically kind of dabba, okay. Top is there. Here sun rays are coming, or light is coming, H nu, okay. And once it is coming, but what are the properties we need to know? And it has metal contacts at thin and top and bottom. Clear? Again heavily doped. Heavily doped N type. These few things, whichever is important, I am giving it. Okay. You can understand like this. P here, depletion region, a big one, and N here. Okay. So the light is coming here in the depletion region. 3 steps here it has. It has 3 steps. What are those 3 steps? First, generation. In this step, what happens? Whenever light comes in this step, whenever light comes, falls here, it generates electron hole pair. It generates electron hole pair, because electrons in this with the energy they split up. So second step, separation. Second step, separation. So electron once generated, what it will do? Electrons once generated, what it will do? It will move towards the N type, holes towards the P type. Yes or no? थोड़ा बाकी है. So whenever the electrons are moving towards N and P type, electron we collect it at top and holes we collect it at bottom. That's it. Clear? Chalo. Okay, let's see. So you all know about logic gates, or do you want me to teach? AND gate, OR gate, NOT gate. So you know this is analog signal. This is digital 0 1 0 1. Okay. Now we have 3 basic gates. We have 3 basic gates. What are those 3 basic gates, students? AND gate, OR gate, NOT gate, and 2 universal, NAND and NOR. You all know about digital, what to say, logic gates. So you don't want me to teach? It's done. Can we go to the PYQ, or anybody wants me to teach? You all know no, the basics. I'll just show one shot, 2 minutes. NOT gate like this. What it does, if I get a current of 0, it will change to 1. If I get 1, it will change to 0. OR means plus. OR means plus. If it is x, y, it will be x plus y. AND means multiply. AND means multiply. X, y, x dot y. Clear? Chalo. Do tell me everybody, just 1 minute is left. Chalo. I'll just show. NOR means not plus OR. First do OR and put a NOT. So if I do OR, I'll get x plus y, and then put NOT means a complement. NAND, first I did the summation, multiplication, sorry, x dot y, and then put a bar, means I did the complement of that. Done. Clear everyone? Clear everyone? Chapter is done, everybody. Chapter is done. We'll go for PYQ. We'll start the PYQ, students. Clear? Clear, students? Any doubt? Chalo, chalo. Let's start the PYQ. Give me 1 minute. We'll start the PYQ. See, you cannot say it is enough, but first round, yes. First round, that is more than, because you won't be able to remember. After that, extra questions you can do of CT because it also repeats from there. So once you have done these two, you'll have at least 30 to 40 questions in your this part. If you go through all the concepts, that should be at least enough. Until unless something new they are putting up, okay, it should be enough. Otherwise, if you see, if you want, what do you say, like that way you can practice as many 1000 questions also, it should not be enough. It can come from 1001. So the concept part, whatever the concepts is there in the book for what is it, semiconductors, if you have gone through all, that should be enough. You can use it and you can solve it. Clear, Karthik? See, focus on concepts, bro. Focus on concepts, because questions, how many you will do? It will always be less. If you have done 1000, somebody will be sitting on the exam who has done 2000. So, सर 17th को फिजिक्स केम है, तो 16th को क्या करना चाहिए? तो पढ़ाई करना चाहिए. फिजिक्स एंड केमिस्ट्री आधा आधा डिवाइड कर लो, या बेस्ड ऑन क्या बोलते हैं, बेस्ड ऑन हाउ गुड यू आर इन केमिस्ट्री और इन फिजिक्स, ठीक है, वो आपको अपने प्रायोरिटी के हिसाब से यू हैव टू डिजाइन अकॉर्डिंग टू योर प्रायोरिटी. Chemistry, if you can score more and you know that these two chapters, if I revise, all will be done, go for that. If you're seeing no, physics is very bad, so in that case I want to revise physics. Chemistry also I'll get 45-50, so then go for physics. Check yourself bro, अभी से टेंशन मत लो. 16th को एक बार कॉल करना, ठीक है, we'll have a discussion क्या हाल है नहीं है. अभी अभी का सोचो, today what I have to do, tomorrow what I have to do, ठीक है. 16th का देखा जाएगा 16th को. Till then, if you have done every transistor is removed from the syllabus. CBSE, what to say, CET and COMEDK both. It is removed directly from the. They have removed the transistor. That's why you all are saved. Otherwise, damn good questions comes. Alpha again, beta again. Bio मर गया है. मर जाने तो bio को, bio तो ऐसे भी. You are preparing for medical also, Sandesh. कम से कम बीच बीच में थोड़ा सा पेड़ पौधों में पानी डाल के फोटोसिंथेसिस देख लेना, ठीक है. कम से कम कुछ तो जिंदा रहना चाहिए. चलो, I'm putting up the semiconductor paper. सिलेबस कहाँ है? सिलेबस वेबसाइट पे है, कॉमेडके का डायरेक्ट उन्होंने लिखा है, एनसीईआरटी, ठीक है. मल्टीटास्किंग संदेश. See again, it is not enough, ma'am, but it is good. Like most of the questions, 80% at least we can say that you can do it from the previous years, what you say, formulas part. 20% they can trouble you, where you have to apply a bit of more of brain part, but 80% yes, you can do. It can change, weightage sometimes changes also. Thought of writing NEET, but now interest on NEET went off. How bro? Suddenly NEET interest went off. इंजीनियर्स फिर भी बहुत ज़्यादा है, डॉक्टर्स फिर भी कम है, ठीक है. कंपटीशन टफ है, बट स्टिल पीसीएम भी रख के कुछ भी कर सकते हैं. चलो, ये तो स्लोगन कर दिया. हाँ, रख लो पीसीएम भी मुट्ठी में. हाँ, चलो, प्राउड इंजीनियर. CBSE board made a bit worst, ठीक है. Exams were like too extended. Competition is too high for the NEET. Okay, kids who are scoring 630, 640, 650, not getting into AIMS. So around 690, 700, 710 for AIMS. Okay, so competition has gone up. So work hard. See, competition has gone up. Others, if they can study, you also can study. Simple, correct? Chalo, we'll start from the last part. We'll come back to this. So the first question on your screen of 2021, okay, 3 photodiodes they have given. Sir, about BSc Agriculture, your opinion? Not bad. A lot of startups are coming in. So solving question paper of past year is okay. Yes, definitely. I've already given chapter wise past year's question paper in the app. Do download the app and solve it in chapter wise format also. No issues. And before the exam, we'll be putting up bit delayed. We are going in the test series. Do take that. You will be able to do it. It is strictly based on previous year's questions only. Chalo. Shall everybody try the first question on your screen for the PYQ? Your time starts now. Let me put the timer. No issues, ma'am. Chalo, Swam gave the first answer B. Half Moon C, Sandesh C. What about others? Try it. Otherwise, I'll tell. Right or wrong doesn't matter. Whatever your theory is going, concept is going, okay. That yeah, this is correct. Go with it. So at least either you are right or you'll be able to correct it. So what is the question given? 3 diodes are there. So time is up now. So I'll just show. 3 diodes are there. D1, D2, D3 made up of semiconductors having band gaps of this. Okay. Which one will be able to detect light of 600 nanometer? Now something we have to do of this. They gave us 600 nanometer for some reason. What is that? Convert into energy form. How much energy it will be? E is equal to h nu or hc by lambda. We all know. We have learned dual nature and everything. So put up h is what? 6.6 into 10 power minus 34. C is what? 3 into 10 power 8. And lambda what they have given? 6 into 10 power minus 7. 600 nanometer means 600 into 10 power minus 9. So 6 into 10 power minus 7. And if I want to convert into electron volt, I'll divide by charge of electron. So after doing all that drama, I got 2.06 electron volt. Now if you see, the incident radiation that is coming to it is 2.6 electron volt. So which one is higher? Which one can detect it? Which one can detect? See, 2.5 there is energy gap. So what will happen? Between this VB and CB, the gap is 2.5. Even if my photon came of 2.06, it will be like my electron will take a bag from here and half it has to come back to home. No party. Correct? Okay. So the other person, VB here it is 3, CB. The gap is 3. He like, sir, I took all the money and everything from dad, but in between we have a shortage. So I started from home, went halfway to what? Kashmir, and halfway I have to come back. Why? My energy is what? 2.06 only. How much needed? 3. So if the gap is 2 EV, then I can do. Correct. So which one we can do? D2 only. Clear everyone? Clear everyone? Yes, no, yes, no. Got it everybody? Got it everyone? Got it everyone? Yes, no, kids fast. Chalo, let's see next. Everybody got this one? Try the next one. Identify the incorrect statement fast. बोर्ड्स पे भी था ऐसा क्वेश्चन, गलत करके आया क्या बोर्ड्स में संदेश? बोर्ड पे सही किया है ना? चलो नेक्स्ट क्वेश्चन फास्ट. Do not get stuck in one question, because in exam also if you're not able to get one question, doesn't matter, the whole 59 questions are waiting for you, bro. If you're writing one paper of CT, if you're writing COMEDK, then 179 questions are there still to be solved. So come on, focus on the next. Purvika ma'am, about BSc agriculture, I don't have much idea, but it is going good right now. Because of the startup culture and organic farming and all, it is going good. D. Okay, Purvika also D. Identify the incorrect statement. When a PN junction diode is forward biased, the width of the depletion region decreases. Forward bias decreases, correct. A PN junction diode in reverse is reverse bias, the barrier potential increases. A photodiode is operated in reverse bias. In LED is lightly doped, which emits spontaneous radiations on forward bias. So just now we did LED is what? LED is what? Why it is wrong, students? Why it is wrong, LED? Why D is wrong? So LED is heavily doped with forward bias condition. Chalo, good. So small details is important. That's why I've given all the details. सर मुझे एग्जाम में गेस करना आता नहीं, टेंशन में कुछ भी मार्क कर देते हैं. चलो पहले तो टेंशन हटा दो, टेंशन से कुछ होता नहीं है, ठीक है. Today also I told everybody the Chinese proverb, remember it. Okay, it helps a lot. If there is a problem, and let's say this is a problem and there is a solution, then no need to worry, work on the solution. And if there is a problem, there is no solution to it, then also no need to worry, because the problem is there but solution is not there. By worrying you can't do anything. Okay, so first thing is stop the worry. Worry removes us from doing a lot of things. Okay, sure. And you have to manage for test papers. What you have to do, you have to do a time management, student. You have to do a time management, half moon. Okay, so like you have to sit before, like let's say 13th 14th, one paper will do, like you have to finish the test in like 2 hours or 2 hour 30 minutes, and then save some time for doing some extra guesswork and all that. I have a question for KCET 60 minutes or 70. Do the half of it. 60 or 80, do the half. Average, find it out. You have to work on that, but it is a good big part. Okay, if you are having tension, you won't be able to think rationally. And when we don't think rationally, we do tend to do more mistakes, bro. So this is, you have to take care later. Okay, slowly you have to build that part. A lot of students, what do you say, one of my friend, he used to, like, he was a topper, you can say, but what used to happen is normal classes he used to top in JE and all that, but whenever he used to go for exam, he used to be so much in tension mode. He used to get 200, 210, and normal exams of, what do you say, college or any other competitive exam here and there, they used to get 350, 340. Okay, so tension, you have to remove it. Chalo. Next, what is the output? Next, everybody, what is the output? चलो एवरीबॉडी, चलो somebody wrote बी संदेश ने आंसर हटा दिया, बी आ गए। चलो देखो इनपुट में व्हाट इज दिस, व्हाट इज दिस गेट स्टूडेंट, क्या ये नैंड है या नॉर है, क्या ये नैंड है या नॉर है? जस्ट नाउ वी मेड नैंड और नॉर, क्योंकि देखो एक गेट तो है, कोई ना कोई एक गेट तो है, उसके आगे फिर रसगुल्ला भी है, इसका मतलब कौन सा गेट है? अगर मैं इनपुट x और y डाल रहा हूं, यहाँ पे क्या हो जाएगा, x डॉट वाई बार, अब यहाँ पे जा रहा है x डॉट वाई बार, x डॉट वाई बार, तो क्या हो जाएगा, होल बार, तो क्या हो जाएगा एक्स वाई। तो कौन सा गेट बिहेव करेगा, विच गेट इट विल फॉर्म, इट विल वर्क एज विच गेट, बी एंड गेट। चलो चलो गुड बच्चों, गुड। So 2021, 2021, 3 questions came and you all very properly solved it. Let's see who can solve this question. 2022, 2020, 2020. चलो बच्चों, let's see. So the question is, a 220 volts AC supply is connected to a between the battery, and what is the potential difference across the capacitor? What is the potential difference across the capacitor? A lot of people, they gave answer how much? A. So we know maximum potential difference, maximum will be what? VRMS into root 2. So correct. 220 by root 220 root 2. Clear? V max is equal to VRMS. Done. Clear everyone? Chalo. Chalo Sandesh sir. Next question. A positive hole in a semiconductor is artificially created particle, antiparticle of electron, vacancy created when the electron leaves a covalent bond, absence of free electron. The first answer came from Pavitra ma'am. Let's see about others. D or C student, D or C? C. Electron and hole together they are there. The moment electron leaves out its place, a hole will be created. They're all bounded. Okay. It leaves, a hole will be created. So what will be? And plus, whenever a covalent bond is broken, what happens? Whenever a covalent bond is broken, our electron in a hole is what? Separated. So it means it's a part of a vacancy created when an electron leaves a covalent bond. Clear? Chalo. Next one, fast everybody. Nice observation, Sandesh. I'll show you a few questions, 10%, but in exam, don't what do you say? Hope that your all the question falls in the 90% category. If it falls in the 10% category, then you're gone. Chalo everybody, Sandesh, C, everybody see. Chalo. So you don't want me to explain? I will get to know about the team, don't worry. Once the exams are done, we'll introduce. We have a designer, we have a coder. A lot of people are there. चलो एक सर्किट को सीधा भी देख सकते हैं. You can see that. वो दे सकते हैं बट देते नहीं है. ठीक है. So everybody is C correct? Yes, no? So your 0 sending 0 from here, 1 from here. Correct. So now what will be the output at P and Q? You all are saying 0 and 1. Anybody explain? Let's see. A lot of people they got answer. Let's see. Anybody who can explain? चलो, I'll only explain. Answer is correct. But how will we form? It's a bit big one. Okay, if you want to form it, इसमें क्या explain करना सर? At least 1 is 0, ठीक है, output is 1, so Q is 1, चलो, not bad thinking, चलो, correct, चलो. So half moon, do you want me to explain? Or you got it? The concept is simple only. See, similar type of question again, you can get same thing. I'll show both also. Same question, just now this time they have given NOR gate. So in NOR gate, students, what happens? We get A plus B whole bar. Okay, correct. So if you see the first gate, I'm explaining this part. If you see the first gate, what happens? If A is equal to 1, so 1 plus either 0, 1 plus either 1, both you will get what? And if you do a, what do you say, what do you call complement, you will get what? Clear? Now for 2, gate B, 0 plus 1 or 0 plus 0, what you will get? Here we have two options. So here what will happen? So here we are getting from 0 part. So from 0, if you are getting 0 only, not this one, 0 plus 0. So what will get? 0, 0 bar is 1. Clear? Chalo. Good. Try this one. संदेश को सीधा सर्किट चाहिए था. Try this one. What will be the guess answer here, Sandesh? देखो ट्रिक अच्छा है बट कंसेप्ट साथ में रखो, ठीक है. ठीक है, सर्किट इजी है, थोड़ा सा अगर सिंप्लीफाई कर लिए तो सर्किट बहुत ही इजी है. ठीक है, ट्रिक के भरोसे नहीं रहना बच्चों. ठीक है, कंसेप्ट रखो, ट्रिक करना है ताकि फास्ट आप हो सको. यू विल बी फास्टर एंड वंस यू हैव डन अप्लाइड द कंसेप्ट फास्टर, यू कैन चेक. करंट इलेक्ट्रिसिटी इज लाइक मंदिर का घंटा, कोई भी आके बजा जाता है, ठीक है, तो इट कैन बी इंट्रोड्यूस एनीवेयर, मैग्नेटिज्म में, कभी इधर में, मूविंग चार्जेस में, कहीं भी आ जाता है. चलो ट्राई करो, बहुत सिंपल है, ज़्यादा टफ नहीं है. How to simplify complicated circuit? I'll show. Once you try, I'll show. Chalo everybody, let's see. A lot of people they gave answers. So can we simplify the circuit? A B C D चल रहा है sir. A B C D मत चलाओ यार. So this type of complicated circuits questions, how much will be there? 1, 2. Complicated circuit, they can't give everything, no. Now, how do we simplify this circuit? How do we simplify this circuit? So if you see, here we have from where to start, students? What do you think? From where to start? These three, what can I say about these three? Are they in series or in parallel? What about it? What can I say about this? See, just focus on this part. Everybody just focus on this part. Okay. You can see that I can make a circuit like this. This one parallel. These two series but together parallel. Just tell me, if I pass a current from here, what will happen? It will go, let's say I1 current. Here it will break I1, I2. Here it will go the same current I1. Sorry, if I am passing the current I here, it will go I1 here, same I1 here, it will go I2 here, and again it will combine here and it will give me I. So what you see, these two are in series. So one series, this in parallel, this in parallel, correct? Everybody understood this part of the circuit, everybody understood this part of the circuit, yes or no? Everybody understood this part of the circuit? वेलकम, डोंट हैव पेशेंस किड्स, ओके। चलो पहले एक बार देख लेते फिर ट्रिक भी लगा लेंगे, चलो। सो व्हाट वी आर गेटिंग इज द सर्किट इफ यू सिंप्लीफाई, one battery, 1 ohm, 3 ohm, 2 ohm, and then again this part if you see it is connected in parallel, and this part if you see we can make it like this connection. Tell me everybody is able to understand. Tell me if you are all able to understand. This is 1 ohm, 1 ohm. The last part I simplified, 1 ohm, 1 ohm. So if I want to solve this, what I'll get? 1, 1 parallel, so 1 only. And this one is what? I can make it 2 and remove this. So 1 by R is equal to 1, 1 plus half, correct? So what you will get? 2 plus half. सर मिडिल वाले को सीरीज होता है, कौन सा मिडिल वाला संदेश ब्रो? करंट देखो टूट जा रहा है ना संदेश, व्हेन आई एम सेंडिंग अ करंट फ्रॉम हियर, सो करंट इज ब्रेकिंग, इट इज गोइंग इधर वन पार्ट हियर, वन पार्ट दिस साइड, ठीक है? और फिर ये वाला करंट जो है इसके साथ सेम हो रहा है, इस वाले के साथ, फिर यहाँ आके ये मीट कर रहा है, और यहाँ से इसका जो करंट है वो मीट कर रहा है, तो इन दोनों का करंट तो डिफर हो गया ना, ठीक है? चलो, so what we got here students? So 2 plus half, how much? 5 by 2. So R is equal to what? 2.5. What about this side? What about this side? What about this side? अब इधर का थोड़ा सॉल्व कर लो. What we have here? 3 and 1 in parallel. 3 and 1 in parallel. So what will happen? What will happen? One more concept is there, but if you are able to apply, we can apply KVL and solve. But we have to check. Symmetry also we can apply. चलो कोई बात नहीं, कोई बात नहीं, ठीक है, कोई बात नहीं, डोंट वरी, ठीक है? तो आंसर क्या होगा बच्चों? यहां तक तो आ ही गए, थोड़ा और आगे चलते थे, ठीक है? So once you have matched these two are in parallel. So 1 plus 1 by 3. So what you will get? 4 by 3. So R equal to 3 by 4. So now we have 1 here, 3 by 4 here, 5 by 2 here, and a 2 here. Clear? थोड़ा बड़ा हो गया, देखते हैं if we can make it a bit more smaller. चलो कोई बात नहीं, इस पे हम लोग बाद में आते हैं एक बार फिर से. We can make it smaller. This is the basic way we can do, but it is getting bigger. In exam, we should not go for this bigger. Something should be there. Let me check once, okay? We'll come back to the this question again. This is not for your part. Try everybody try this. I'll again come back to that. Don't worry. We understood the concept, but it is going a bit more bigger. Should not go that much bigger. So we have to figure out. Nirash nahi hona. We have to figure out something in a much smaller way. Chalo, everybody try this, try this. This one is simple. Let's finish it off fast. It's almost 12 fast. Hi, Lonely. Answer is 0.4. Chalo, tell me the answer for this. 0.4 मिल गया. बट थोड़ा और छोटा करने का कोशिश करना, देखते हैं. We'll figure out. Don't worry. Try this one fast, everyone. Good for you, bro. Lonely. Chalo, fast students. The conductivity of a semiconductor increases with increase in temperature because the moment we apply, we give them more what energy in terms of temperature. What will happen? Kinetic energy will increase. Then what they'll do? Come on, tell me the answer fast. चलो बच्चों, आंसर. Focus on answer. So what will be the answer? Happy birthday, Upmoon. So Soham said A, Sandesh A. 1 second, bro. Now see everybody, चलो पहले आप लोग बर्थडे सेलिब्रेट कर लो. Done everyone, चलो let's focus on the question. Bye lonely. Now see here everybody, the conductivity of the semiconductor increases. So conductivity is increasing with increase in temperature. Okay, so you have increased the temperature, conductivity has increased. Now what is the reason for that? Now what happens? What do you mean by relaxation time? Just think on it. Chalo, focus on the question, students. Eyes by, okay. Chalo. If you are there in IT, you should not disturb others. Let them be in some good place, okay. Chalo everybody. Now understand everybody. See, we have less time. So what is happening is, understand the concept of relaxation time. Anybody tell me what do you mean by relaxation time? What do you mean by relaxation time? Just think a bit. We have already done in current part. What do you mean by relaxation time? Anybody, what we have learned about the relaxation time? What basically we mean? Relaxation time is nothing but the gap between two electronic collisions in a conductor. Correct. So if you provide more energy to the electron, bro, if you provide more energy to the electron, will the relaxation time increase or decrease? Will the relaxation time increase or decrease? Understand everybody. Okay, you're telling A as the answer, try to understand. You have made electrons very charged. Now they'll, what is it, collide more because they're more faster. So they'll collide more or less? Tell me fast. Now they will, when they have more energy. Earlier, let's say you all have less energy. Now you have more energy. So what do? You find a person, you start a fight, correct? You find a person and you start a fight. So here, understand students, what will happen? A option won't be correct. So what will be the option? B option. Number density of the current charge carriers increases. Earlier the electrons were like, so I'm almost dead, done, okay, I can't participate in what is a conduction. Now they all also say, oh, we got new energy. So what we'll do? We'll try to contribute. Clear? So relaxation time decreases, but the effect of decrease in relaxation time is much less than the increase in number density. Means you are able to charge a lot of number of electrons. If you start energy is giving energy to them, so what will happen? You will be able to charge, the number of electron density will increase. C point, number density. See, the last line you have to think again. Okay, So very important. See, they can just change option and give the same question. So there, if you don't understand what each option means, it will be a difficulty. So that's why when you solve PYQ, okay, previous year's questions, your target is not to get the just answer, to understand what each option means also. Now next is number density of charge carriers. So the number density of charge carriers increases. It is telling here also. Okay, here also. Now it is telling both number density of charge carriers and relaxation time increases. No. Nope. So if you see, we got to know relaxation time is decreasing. So this option gone, this option gone. Now number density is included here also and here also. So number density is increasing here also, and it is telling that the relaxation time is decreasing also. So which option, B or C, Nishat? Which option, B or C? B is telling about C also, B is telling about B also. Clear? B is telling correct about A and C also, A and D also. What is B telling? The option B is telling us that relaxation time is decreasing. It is is given in what is A and D. It is cancelling A and D. It is also telling that the number density of electrons or charge carriers, it is also increasing, and that is basically the point C. So if I'm telling point B, I'm covering C also. I'm covering the wrong part of A also. I'm correcting it and covering it. Correct? Clear? Clear, everyone? So the answer is B. The answer is B. Got it, everyone? So think a bit, students, think a bit. Okay. If you don't think, it will be difficult because we have less time, and if you want to crack in this less time, very good rank. So each question is like a jewelry box, okay, or like a, what do you say, a treasure for you. Per question, each concept, oh, why it is decreasing, why it is increasing, if you get to understand, you'll be able to solve 10 different questions. Clear? Chalo. Not for you all. You can do this. One numerical formula which I have given, you can do this. You can go by Purana trick. We have to check, we have to take all the questions which are having, what do you say, big answers, and we have to check whether it is getting correct or not. Chalo, 18 number. Come on, student, tell me the answer. At least we can check this trick. Let's see later. For the other questions, it is working or not. Chalo. Now tell me what will be the option here. See, you don't have to play with the power. Powers are all same. You just have to figure out what will be either 1, 2, half or 4. Sandesh got B. Which trick you applied, bro, this time? Chalo, everybody see it. See, I gave you only one formula, bro. What is that formula in this maths formula? Ni square equal to Ne into Nh. I gave this. So read the question. The density of an electron hole pair in a pure germanium. Pure germanium means what? No doping. No doping. So what is this? Everybody, this is Ni. So 3 into 10 power 16. On doping with aluminum, the hole density increases to this much. So hole is 4.5 into 10 power 22. Now the electron density, find it out, simple. So Ni square means 3 into 10 power 16 whole square equal to 4.5 into 10 power 22 into x. So this will be what? 9 into 10 power 32 and divided by 10 power 22 is equal to 45 by 10. Correct. So this is like 10 here, and this 10 if I send it here, 11 here. So 9 5s are. So what I am getting? 5 into 10 power x is here. Oh, x is here, no. So 10 power 11 by 5. So what will you get? 2 into 10 power 10. Clear? Chalo, everybody got it? How see, ma'am? How see, ma'am? X is this side, no. So I'll send 5 that side. Clear, Karan? Chalo. Got everybody? Chalo. We'll keep the, what do you say, semiconductor still here. Once again, okay, see here. See, when they say that it is pure germanium means no doping. So N of I is equal to 3 into 10 power 16. When we say they have already doped, they have told about holes. So N of holes equal to 4.5 into 10 power 22. Clear? We already know the formula. Ni square is equal to Ne into Nh. Okay? Just put it in the formula, get it. Chalo, we'll keep the physics till here, everybody. Yeah, Half Moon, you can go. He went or is there? You there, Half Moon? Chalo. ठीक है, फिजिक्स यहीं तक बच्चों, ठीक है. And after 20 minutes, ping me. If you want to do maths, we'll do 1 hour maths, finish it off, okay? Chalo. Or else we'll start tomorrow a bit early, not too early, around what, 1 o'clock. Okay, we'll do that time. नहीं, वो जल्दी सो जाता है, वो सुबह जल्दी उठ जाता है. Used to give me a call morning 5 6 like that. चलो. ठीक है, यहाँ तक रखते हैं. If you want to do class after this also, put up a message, okay? Else we'll do in the morning. Around 1 we'll do, okay? How many people want to do maths right now? Confirm me how many people want to do maths right now. कल कर लेते, ठीक है, चलो। कीप इट क्लियर एवरीवन, एवरीबॉडी ओके? Sandesh sir is too active today. Oh, our sir went for cake cutting. You and Soma are ready, I know. Okay. Is there in the app? Let me ask to send the cake for us. Chalo everybody, I'll be there. What do you say? After 20 minutes, I'll check if you all are ready. Okay. Take a break of 20 minutes. Okay. If people are there, I'll take. If not, tomorrow morning. Okay. Chalo. दिन को ऐसा थोड़ी ना कि आप हल चला रहे हो। संदेश सर, मॉर्निंग में क्या कर रहे हो? कोई डिस्टर्बेंस नहीं, दिन में कौन आके आपको डिस्टर्ब कर रहा है बताओ? मुझे टेस्ट पेपर का थोड़ा सा काम करना है, इसलिए क्लास ले लेते हैं, बट टेस्ट पेपर का थोड़ा है। अगर आप लोग देखते हैं, आप लोग एनर्जेटिक हो तो ले लेंगे, ठीक है? अदरवाइज विल टेक टुमारो। चलो, विल कीप इट टिल हियर, ओके? चलो, अब मॉर्निंग में थोड़ा साउंड होता है, इवनिंग में थोड़ा पूरा सन्नाटा रहता है। हाँ, कल मॉर्निंग केमिस्ट्री कर लो। मेरी क्लास अगर स्टार्ट भी होगी तो 12 बजे के बाद। चलो आप सो जाओ, आप अभी केमिस्ट्री पढ़ लो, ठीक है? मैं अराउंड 12, 1 या 2 बजे के अराउंड शुरू करूंगा। आई पुट अ मैसेज बिफोर दैट, ठीक है? चलो, अब केमिस्ट्री करो, कर लो, ठीक है? डोंट वेस्ट टाइम संदेश, डू केमिस्ट्री। चलो कंप्लीट कर लो। जो जो बच्चे जाग रहे, केमिस्ट्री कर लो, ठीक है? चलो, गुड नाइट एवरीवन। बाय एवरीवन।